recall, remember, based off identities, tan x is the same thing as sine x over cos x. So how can we use this to determine the derivative of tan x? So I can do it two ways. I can either use my quotient rule, for sine x over cos x, or I can use my product rule, which is just sine x times cos to the negative 1 of x, which you can also write as cos x to the power of negative 1. So let's try to use my quotient rule to determine the derivative of tan x. So I know the derivative of tan x is the same thing as finding the derivative of sine x over cos of x. So remember, using our basic trig derivatives, I need to use my quotient rule, which is my derivative of the first times the bottom function minus the derivative of the second times my numerator, all divided by the denominator squared. So my p of x, which is sine of x, is going to give me cos x, and the derivative of q of x, which is cos of x, is going to give me negative sine x. So now what I can do is I can apply my quotient rule, which is cos x times cos of x, minus negative sine x times sine x, all over cos squared x. When I simplify my numerator, I get cos squared x plus sine squared x over cos squared x. Based off grade 11 and grade 12, what does cos squared x plus sine squared x give me? 1. Which means I get 1 over cos squared x. And if you guys remember, back to identities again, what does 1 over cos squared x give me? What's the reciprocal function of, thank you, secant squared? No, not sine squared, secant squared x. Okay, remember, 1 over cos squared x is the reciprocal function for secant squared x. So now I'm able to do these questions. So I'm able to do y is equal to 10 to the power of 3 times x. So based off that little spiel I gave, how else can I write 10 cubed x? So I can write this as y is also equal to 10x cubed. Okay. Now I can basically use my power of a function, which means that my derivative is just going to be, bring the 3 into the front, times 10x squared. And now, remember, I can also write 10x squared is the same thing as saying 10 squared x. And from the previous example, what is the derivative, or what does tan squared x give me? So what is the derivative of tan x? What does that give me? Secant squared x, which means that this can also be multiplied by secant squared x, which means my derivative is 3 times tan squared x times secant squared x. Okay, again, remember the power is just written as that notation, okay? You can write it as tan x all to the power of 3 if you really wanted to. So for the next one, I have tan of 2x. Remember basic trig functions. So remember, I need to take my derivative of tan first, which I know is secant squared x. And then I can take the derivative of my bracket. So what's the derivative of 2x? 2. Multiplied by 2, which means my derivative is just 2 times secant squared of 2x. So now let's see what more we can add. So the derivative of composite tangent functions of y is equal to tan x. So remember, guys, this is the same thing as my chain rule from our regular derivatives unit of polynomial functions. So if I have tan composed with a function f of x, then dy over dx is just the derivative of tan, which is secant squared, times the function that was given to us, and then we multiply the derivative of that function f of x. So let's try to take that rule and apply it to 2a. So for 2a, I have y is equal to tan times 2x squared minus 3x. So as per the rule, my derivative of tan is secant squared times 2x squared minus 3x multiplied by my derivative of that function f of x that's inside the bracket, which is the same thing as 4x minus 3. And if I simplify it, all I'm doing is bringing the 4x minus 3 in the beginning, which simplifies to 4x minus 3 times secant squared of 2x squared minus 3x. So now my next one, I have y is equal to tan cubed of cos x. So again, that's just a notation. I can also write this as tan of cos of x all to the power of 3. So what I need to start with is my power of a function. So I get 3 times tan times cos of x to the power of 2. And then what I can do is apply the derivative rule for tan if there's a function attached to it. So again, this is my tan, and cos of x is like my f of x. So this can be multiplied by secant squared of cos of x. And now I can multiply by the derivative of my function f of x, which is negative sine x. Oops. I ran out of room, but that's okay. So if you guys can see the negative sign over there. So now I can simplify. Which means I'm left with negative 3 sine x times tan squared cos x times secant squared times cos x. Remember, this middle term over here, all I did was change the notation. So tan times cos of x all squared is the same thing as saying tan squared times cos x. So hopefully you guys aren't going to be afraid of that notation. Remember, you can swap vice versa, back and forth. Tan squared x is the same thing as saying tan x all squared. Is everybody starting to understand that this whole notation thing with the power being I guess distributed on the outside? Perfect. All right. So now we have the next one, which is y is equal to tan squared of x squared plus e times tan of 2x. So my first part can be written as tan of x squared all to the power of 2 plus e times tan 2x. So let's worry about my first part first, which is tan of x squared all squared. So again, I'm going to use the power rule. So y prime gives me 2 times tan of x squared. Okay? And then remember, with my tangent derivative is going to be secant squared of x squared. And now I can multiply by the derivative of x squared, which is 2x. Now I need to take the derivative of e to the power of 10, tan of 2x, which just gives me e to the power of 10 of 2x. And again, same rules apply, times secant squared of 2x multiplied by the derivative of the inside function, which is just 2. So now when all is said and done, I can simplify. I get 4x times tan of x squared times secant squared of x squared plus 2 times secant squared of 2x times e to the power of 10 of 2x. Again, all I did to get this front term 4x was take my 2 over here and multiply it by 2x, which gave me 4x. And last but not least, I have cos cubed x times tan of x. That's fine as long as when I look at it, it makes sense to what I wrote in order. But if you want to keep it in a different order, say you want to start with 2 secant squared 2x and e tan to the 2x, and then have 4x 10x squared. After that is completely fine with me. So the next one we have is y is cos cubed x times tan of x. So I can also write this as cos of x to the power of 3 times tan x. So I have my p of x and my q of x, which means I need to use my product law. So let's try to find the derivative of p of x, which is going to be 3 times cos squared x times the derivative of cos x, which is just negative sine x. And now I can find the derivative of tan of x, which is just secant squared x. So now I have my derivative of p of x and my derivative of q of x. So now my derivative is going to equal 3 times cos squared x times negative sine x times the original function q of x, so multiplied by tan x, plus my derivative of q of x, which is secant squared x, multiplied by cos cubed x. So now let's rearrange things and try to make things in order so that we can cancel some stuff out. So when I reorder this, I can get negative 3 sine of x times cos squared x. How else can I write tan x in terms of as a ratio? Sine x over cos x, perfect. And I know secant squared x can also be written as 1 over cos squared x multiplied by cos cubed x. Let's see, I'm going to give you guys a couple of minutes to try and simplify this. And when you have the final answer, please type it in the chat. So again, try to simplify this expression and then type your answer in the chat, please. Okay, so let's see. Not necessarily. So Mohammed. So what this does is my exponents cancel out, which means I'm left with just cos x. This cancels out, and I'm left with just cos x. So I'm left with negative 3 times sine squared x cos x plus cos x. So that's what it would simplify into.